Hi everyone. In this lecture, we will be understanding everything about lists. Alright. So as we knew how to create a list, there are basically two ways. One is you use the list function, and the other is you just put a third bracket and start writing or incorporating all the elements inside it. I prefer the second method. You can prefer whatever you want. Both are exactly the same. All right. So the different operations, as I had already mentioned, that can be performed using lists are: one is accessing all the items that we have also seen in strings, looping through lists, appending and inserting, as well as extending the list, concatenation, copy of a list, sorting of the list as well. We'll also be understanding about replacing any values, that is elements, let's say 2 and 3. So let's say we want to replace 2 with, let's say 4. So we can do that as well. Removing any items from lists, popping out any elements from a list, deleting the entire list or any items inside the list, clearing the list. So again, the basic difference between clear and delete remains that delete deletes an item, while clear clears the list. The list still remains. We'll be understanding with when we go ahead. And also we can perform some mathematical operations in a list. Right. That said, let's start. Now, what we see is that accessing the items. Accessing the items start with the first process. Here we see that. All right. Let me take this list to be the basic formation. What I've seen here, I have taken a list li containing apple, banana, mango, and the number or integer 2. All right. Now, the first item is very similar to what we have learned in strings. The first item, so li equals to apple and whatever it is, apple, mango, and everything. Okay, let me take it as well. Yeah. So this was what the list is, and let me put it over here. When we want to extract the first element, this was the 0th element, this is the first element. So when I want to extract the first element, we write li of 1. And what do we get? We get banana. As I said, this is the first element. Same way as what we do in strings, the elements can be taken in a backward position as well. So when I say li of -1, I should get 2. That's what I got. I can also take li of -2 and we'll get mango in that case. So entirely the same way as strings work. Now again, like strings, we can also have the entire list taken. When I put this colon, and when I want to reverse a string, the simple thing that we do is double colon and -1. So the entire concept that we have learned in strings for accessing any elements or items is as similar to that for list. So I hope this is quite clear to you. So let us move to the next operation, and let me clear it out. Yeah. Now coming to looping through a list. So that is very simple. As we have already learned about loops, so the same thing can also be done inside a list. So for I in li was the list containing the entire, this was the list li. So when I do for I in li, print I, all the elements one by one would be printed. Apple, banana, mango, and 2. And that's exactly what has happened. Another way of doing the same is, as I've already mentioned in loops, the concept of range. So for I in range, len of li. Now len is a function which gives me the length of the list. All right. So let's understand. My list is this, right? Apple, banana, mango, and 2. What is the length of the list? How many elements are there? 1, 2, 3, and 4. So let's check it out. Len of li. It gives me 4. So exactly that is what happening over here. For I in range, len of li. That is, we can replace len of li here with 4. So for I in range 4, print. Okay, let's check it. So for I in range 4, print I. What should you have got? You should have got 0, 1, 2, and 3, correct? Let's check it. So I exactly get 0, 1, 2, and 3. Now, I put this particular thing into use, li of 1, li of 2. So what I do over here is, instead of printing I, what I do, I print li of I. That is, each time I is increasing, li of I, it is accessing different elements. So at first, it would be accessing li of 0, that is the 0th element, which is apple, right? Then it would be accessing li of 1, which is banana. Then li of 2, which is mango. And then li of 3, which is 2. That's what here it's happening, right? Let's check it. That's exactly what has happened over here. So I hope you understand how I actually manipulated using the range function to get the same output. All right. Now coming to the next operation, which is append. So as I have already mentioned, append adds an item at the very end of the string. So I already had li to be apple, banana, mango, and 2. Now when I write li.append orange, this orange comes and gets added at the last. So after 2. And that's what has happened over here. After 2, orange comes. Now what is insert? Again, as I have mentioned, it is nothing, just an extension of append, wherein I also mention the specific position where I want to insert my required element. So I want to insert orange at the second place. This was the 0th element, this was the first element, and this is the second element. So I want to place orange at the second position. So mango would actually take third position, right? So now orange would come here. It would be taking the second place, mango would be taking the third place, and 2 will be taking fourth place. That's what has exactly happened. Apple, banana, after that orange, then mango, and 2. So insert and append are kind of same. However, unlike append, it also takes a positional argument so as where it should place this particular element, while append only adds it at the very end. All right. Now, extend. As I had already mentioned, what extend does is there are two lists. One is apple, banana, mango, and 2. Another is good and hood. So when I extend it, let me grab my pen real quick. Yeah. So when I extend it, what happens? Good and hood is appended at the last. but not as a list, as simple elements. And that's what has happened. And as I have mentioned, the difference between append and extend is that append adds a single item. So when I use, so let's see what happens when I actually use append instead of extend. So this is my list. And this is the list that I want to append. So instead of extend, I'll just write append. See what's, okay, I also need to call li. See what's happening. So what actually happened is, when I used extend, the items got added. But when I used append, after 2, a single item got added, and that too as a list. Right? This is the entire difference between extend and append. Now, let me be very clear with one more thing. Can I still access, let's say, hood out of this? Yes, we can. How do we access hood over here? So let's say I wanted to access hood. So what I'll do is, I'll just write li of. This is the 0th element, this is first element, second, third, fourth, and 5th element. So when I write li of 5, I get hood, right? Now, can I write li of 5 over here? Can I do that? It would be giving me an error because this is the 0th element, 1, 2, 3, and this is the 4th element. So li of, okay, I have not run this. That is the reason it gave me the answer. Now let's check it out. So it's throwing me an error. Index out of range. Correct, because there is no index. So what I can still do to access hood is, let me check. So when I say li of 4, I get this 4th element as a list. Now I get both good and hood. Say, for example, I want to access hood. I want to go inside this list and access the first element, 0th element, and this is the first element. So this is what I do. And I get hood. Also, I can access the 0th element to get the good. Right? So this is how we access elements when it's present inside lists, inside lists. All right? So this was all about append and extend, the differences between them. Now coming to concatenation. What does concatenation do? It just adds the two lists together. So list 1 gives me 1, 2, and 3. List 2 gives me 4, 5, and apple. So when I do list 1 plus list 2, I get 1, 2, 3, 4, 5, and apple, both concatenated. Same as that we get in strings. Now coming to a very important operation of list, how do we copy a list? Okay, so for this we need to understand certain things. So let's say string. When I write a string, as I have mentioned how strings are accessed, if you remember, variables are nothing but locations or pointers to memory places. So if a equals to 23, this is how it operates. If b equals to 23, it points to this particular place as well, right? This is how the entire thing happens. Now, an important thing what happens in list is, let's say list 1 contains this particular list, apple, banana, mango, and 2. And what I do is list 2 is equal to list 1. Right? So people might be thinking that list 2 is now. So let's see what is list 2, right? Let me check it one by one. So list2 is equal to list1. Let's print list1 over here. Obviously, this is what I'll get. Let's also print list2. Same thing that I'm getting. So up to now, I think everything is cleared. Nothing, no problem. Now, what if I just want to add? So list2 is this, right? What if I just want to add something I want to append to list1? So list1 dot append. Let's say 5. Simple. Now what should I get in list1? No prizes for guessing. After 2, 5 would be added or appended, whatever you want to say. But what would be list2 in that case? It should be same as this. I've done nothing with list2, right? No tampering. Let's check out. Okay, that seems a bit weird. Why? I have appended 5 to list1. How did list2 get 5 appended as well? See, the problem to it, again, this is a concept of data structures, but this is a very simple thing that I have already explained in strings, so I'll be going forward and explaining it. So what happened was list1 and list2 are the same, right? Pointing at the same memory place. And let's say this contained X, and now it is containing Y. But list2 is also pointing at the same memory place. It's not an entirely different list. When we write equals to, it doesn't copy. It only creates another pointer pointing at this particular place. And that is the reason when the elements has changed. Or in this case, another element has been appended. Both are reflected in this 2 pointers. So first understand this equals to does not really copy the list. It creates another pointer pointing at the same location, right? Okay, so we understand that we have not learned how to copy as of now. But then how do we do? Because copying is an important part. So for that, what we do is, there are 3 methods, right, to do that. The first is we use the function .copy. All right, let's take each and everything one by one. So this was list1, right? This was list1, and list2 equals to, right? List2 equals to list1 dot copy of nothing else. So list2 is equal to list1 of list1 dot copy. Now let me check it. Okay, list1. I'm getting the same thing, right? Apple, banana, mango, and 2. What if I put list2? I'm getting the same output. What if I want to append list1 dot append 5? And let me print out list1 as well. I'm getting 5 as the output. And what about list2? No, I'm not getting 5 as the output anymore. So what we do is list2 is equal to list1 dot copy. This is a method to copy, and this is the essentially important and the only method to copy. However, with time, other methods has been developed, but those are developed due to other reasons. This is the primary method that you use for copying. Again, you can use other methods as well. I preferably use other methods. So we'll see what are those. The second method that we can use to copy is we create another list. So what I do over here is, instead of list2 is equal to list1 dot copy, okay, let me remove this and let me show you. The problem still arises, right? So what I do is I create another list entirely. So I create another list. List 2 is equal to list of list 1. Now, what happens is, there was a list called list 1 containing some elements, right? Some elements. And what is list 2 now? List 2 is equal to another list that I have already created, which is equal to the entire list 1. And therefore, it is not a pointer anymore. It's not a mere pointer anymore. It's another list. And now what happens is, the changes will not be reflected. So see, list 1 is now 2, 5, while for list 2, it's still 2. So this is the second method. You create another list. The same thing copy method does, but it creates a list internally. So that's the entire thing. The third method that I normally use is what I do. Here, what you do is you use the slicing method. So what you do is list 1, and you use the slicing with a colon that takes all the elements together. This is also creating a list, but it's more effective. So what happens? Let's see. When I append, 5 is taken into place, but list 2 does not take 5. So these are basically 3 methods we use to copy lists. All right. Let's quickly recap. The first method is the dot copy method. The second method is creating another list. And the third method is slicing. All right. So next time, do not finish or do not think you have copied a list using the equal to sign. This is only you are creating another pointer. All right. Now let's move to the next operation, that is sort. So lists also come with their own built sorting methods. So let's say I've created a list. List 1 is equal to 1, 2, 3, right? List 2 is equal to ABC. What I do is I sort list 1 dot sort. So it is sorted in an ascending way. So here you might not be able to understand what is happening because it's the same thing we're getting. So let me do one thing. Let this be 4, right? And let this be Z. Now see the difference. So list 1 is 1, 4, 3. And when we sort, I should get 1, 3, and 4, right? That is exactly what I've got, 1, 3, and 4. And when I'm writing list 2 is 1, Z, and C, we should get 1, C, and Z when it is sorted. That is what we are getting. The function that is used is dot sort, list 1 dot sort. All right. For sorting in a descending order, what we do is we here just introduce, we here just introduce reverse equals to true. That's all what we need to do. And see, it has been sorted in a descending order. All right. That was everything about sort. Now there comes another important function called sorted. So what is the exact difference? Sort is used to sort the original list, while sorted, if you use sorted, the original list is not changed. So let's take an example. Here list 1 is 1, 2, 3, right? And list 2 is sorted list 1 in a reverse way. That is, list 2 would be list 1 sorted in a descending order. So that's what we do. Sort it and write this. Here, the difference that we get is list 1 would not be sort. So I get list 1 to be 1, 2, 3, while list 2 to be 3, 2, 1. Had we used the sort function, both list 1 and list 2 would have changed. But since we use the sorted function over here, we are getting a change only in list 2 and not in list 1. So I hope you get this particular concept cleared. When you want to change the list itself, you use the .sort method. When you want to change another list and keep the initial list intact, you use the sorted method. Right? All right. Now coming to replace. So what does replace do? It's very simple. You just access the required element that you want to swap. In this case, I want to swap apple with cherry. So what I do is, I have accessed the apple. Li of 0 is obviously apple. And I have replaced that with cherry. Li of 0 equals to cherry. And now when I print, I get cherry, banana, mango, and 2 instead of apple. So that's what replace do. Now coming to remove. What does remove do? It removes a specified keyword. It takes only one argument, and it essentially means that only one item can be removed at a time. We can remove many items, but at a time, only one item can be removed. So what I've done here is, I've taken a list to be the same list, apple, banana, mango, and 2, and I've removed banana out of it. So li.remove banana. And see, when I now print li, I get apple, mango, and 2. So banana has been removed. Now, what if I had 2, 3 occurrences of bananas, right? In this case, I have apple, banana, mango, banana, and 2. Then it only removes the first occurrence. So this particular banana would be removed when I remove banana. And what I get as an output is apple, mango, banana, and 2. So apple, mango, banana, and 2. Had I removed banana again, so let's check out what happens. Now let me remove banana again. Now what we get is no bananas because twice banana has been removed. All right. That is how it operates, the remove function. Now coming to the pop function, it removes the items from the specified index, right? The remove function removes the items. So we explicitly mention which item do we want to remove, while pop is an index-based removal. So we essentially write li.pop and mention the index. So what happens is, when 0th element has been removed, we see this apple, 0th element has been removed. We get banana, mango, and 2. So remove is a, we mention the element that we want to remove, and this is an index specific removal. This is element specific removal. This is index specific removal. And when we use pop, we can also get the removed item. So I have just taken the removed item in a variable, removed equals to li.pop 0. So when I want to take, when I want to understand which is the item that I have removed, I just use removed and I get apple. Apple is the item that I have removed. And the updated list, that is li, now contains banana, mango, and 2 without apple. All right. Now, one important thing, in case we do not mention which index do we want to remove for .pop method, it removes the last item. See here, li equals to apple, banana, mango, and 2. and we have not explicitly mentioned. Here we had mentioned, and therefore the 0th item, that is apple, has been removed. Here since we have not mentioned, it removes the last item. And mango, it finishes now with mango. Apple, banana, and mango. 2 has been removed. Now comes the del operation. The del operation removes the items from a specified index. The pop, what is the difference between del and pop? Pop pops out that item, and that item can also be accessed, right? For del, that item can never be accessed. So that's what happens. Li is equal to this, and we have written del li of 0, right? Therefore, apple has been deleted, and now this deleted item can also never be accessed. Now, unlike pop, if we do not explicitly mention which item do we want to remove, if we write del of li, it deletes the list entirely. The list does not exist, right? That is the reason when I now call li, it gives me an error, because it says the li is not defined. It has already deleted the list. Now in its memory, it cannot recall that anything called li is really defined. And that's how del actually works. Now we come to the clear operation. Clear operation is very similar to that of del. However, it does not delete the list, that is the data structure itself. It deletes all the elements inside the list. So when we write li.clear and then print li, it gives me a clear list with nothing in it. So these were some of the manipulation techniques, manipulation operations rather. And now we come to one of the most important parts, where the list itself can perform all the mathematical operations. Mainly there are 3 operations that it can perform. One is sum. So when we write sum of li, it gives me the sum of the entire elements. So here we get 1 plus 2, that is 3, 3 plus 3 is 6, and plus 4 is 10. So that's what we get, 10. What is the maximum element? We give the function max of li, and we get maximum element here is 4, so we get 4. Similarly, for minimum, we write mean of li, and we get 1. Also, we have already discussed about the len function, right? So the len function gives us the length of the number of elements, or the length of the list. Here it's 3. That's what. It should be 4, right? Because there are 4 elements, 1, 2, 3, and 4. So it should give me 4. And that's what it has given me. All right. So yeah, that's all for today. We have learned lists in detail. In the subsequent lectures, we'll be learning about tuples, sets, and dictionaries in a detailed manner.